Hi, friends. Welcome to another wonderful day of digital learning, distance learning. Today, we're going to start a new unit on conics. This is really just meant to be kind of an overview and an introduction. It is not meant to be a super rigorous unit. We're going to go really quickly through it. There is no test for this unit. There will be a little project, and then we are going to just do a bigger project as our kind of cumulative review of the year. And that project will be kind of fun too. So, really, we are done with the heavy duty stuff for the year, and I'm going to just try to have us kind of just take it easy, but still be productive and exercise our minds and get some stuff done. So, introduction to conics. This unit is on conic sections. I have an anti set for you here. I want you to think about how you can graph an equation if you don't know what shape it makes. And I want you to share your ideas for that in the Google question for your attendance. So go ahead and pause this video and take care of that. Welcome back. Our objective today is to figure out what shape certain equations make, and in that way, we should be able to identify conic sections. This is relevant because digital images are all made from equations. If you watch cartoons, a lot of those Pixar things, a lot of those are made out of equations. Logos for companies are made out of equations, and so knowing what those equations are, then you can program them into a computer and the computer can render the digital image, which is really cool. So we're going to talk about that a little bit later in this unit. So, what is a conic section? I'd like for you to follow the link in Google Classroom or the link in the slides. Or you can just go to Pearson Realize, not Math Excel, but Pearson Realize, and look at this virtual nerd section about what is a conic section. It's going to walk you through, it's going to define it. What I'd like for you to do, your purpose for watching, is to define what a conic section is in your notes, and in your definition, include the names and shapes of each section. All right, welcome back. When we take a look at these conic sections, we can see that section A here is the circle, B is an ellipse, C would give us a parabola, and in this case, D would also likely give us a parabola, possibly a hyperbola. 1 gives us a hyperbola, 2 gives us a hyperbola, 3 gives us an ellipse, 4 gives us a parabola, 5 gives us a circle. So taking a look at these slides, looking at those shapes now instead of being in 3 dimensions and being shapes in the plane, looking at them in the coordinate grid. And I want you to take a moment and identify each of these conic sections and name them. So you can go ahead and pause the video and then come back. All right, let's check your understanding. This is an ellipse. Number 2 is a parabola. Number 3 is a hyperbola. And number 4 is a circle. Okay. So we have 4 conic sections, 4 shapes that are made when we when we cut a cone, the conic cone. And those are a circle, an ellipse, a hyperbola, and a parabola. So, your practice today is going to be related to identifying which of those 4 shapes is made by an equation. Now, we haven't learned much about the equations of these shapes yet. So, today we're going to use our appropriate tools strategically, Mathematical Practice 6, and we're going to see how we can figure out what type of shape this equation would make, where are the lines of symmetry, the domain, and range. And we'll also talk a little bit in some of the practice problems about other key features like x and y intercepts. So if it were me, I would open a new slide, a new tab, and I would go to Desmos and I would graph the equation. So we had the equation x squared, get in here, x squared plus 9y squared equals 36. Okay. And we get this shape. And that shape is an ellipse. Okay. So that's just something to keep in mind when we come back here. What is the shape? Here we go. So the graph, just sketching that graph really quickly, gave us this, which is an ellipse. So then we come back and we can look at the lines of symmetry and see what kind of lines of symmetry we have. And we have a line of symmetry going down the x-axis and across the y-axis. Okay. Another question I asked are what is the domain and the range? The domain is all possible x values, and we see that we go from -6 to +6 in our domain. So our domain is all real numbers between -6 and +6. Our range are our possible y values, and those are between -2 and 2. So all real numbers between -2 and 2. And then some other key features. We have a y-intercept at 2 and -2. We have x-intercepts at -6 and +6. So we can come back in to our slides and we can get those down. Lines of symmetry are the x-axis and y-axis. The domain is all real numbers from -6 to 6. And the range was all real numbers from -2 to 2. Some things that we didn't have in here that we could add in, like we said, was our x-intercepts at -6, 0, and 6, 0, and our y-intercepts at 0, -2, and 0, +2. So that's basically what your practice is today. Use your appropriate tools to strategically. Use Desmos. Your calculator doesn't graph these because your calculator graphs functions, and these are not functions because they fail the vertical line test. To use Desmos and be able to find the graph, the line of symmetry, the domain, the range, the x, and the y-intercepts. Your practice, where you're going to do that, is the Intro to Conics practice set in Math Excel. That is due April 22nd before bed at a reasonable hour. This practice set is designed to only take you about 20 minutes. If you are finding that it's taking you more than 30 minutes, please stop and join me for office hours, and I can help you demystify the work and help you figure it out a little bit more efficiently. Um, the work that we're going to do later this week might take a little bit more time than 20 minutes. So it's a little unbalanced, but I will definitely try not to overload you on this. So, checking in our objective, students will be able to identify conic sections. Hopefully, you know how to put the equation into Desmos and identify which conic section it is: a circle, an ellipse, a parabola, or a hyperbola. For your closure, I want you to summarize in your notes how Desmos can help you match an equation to a graph. In your explanation, it would be really helpful to talk about the x and y intercepts, the domain, the range, and the lines of symmetry. Well, that's it for today, friends. I hope you have good luck with your practice. As always, I am definitely here to help you. And let me know. I am on the other end of an email.